You'll see a notification on your screen that I'm recording, all right? So today we're working on finishing up the lesson on tables of ratios, right? So yesterday we went over the first 12 slides here. We'll go through those really quickly just to remind you guys about what we did yesterday, right? So we saw yesterday, right, the objective is that in this lesson, you're going to be able to make tables of equivalent ratios and also use them to compare ratios. So we basically focused on this first part yesterday on making tables of equivalent ratios. And today, or what you guys also should have done independently yesterday, was you should have already started using those tables to compare some different ratios, right? And if you didn't understand it, you didn't get to it yesterday, I'm going to go over that today. So just make sure if you're confused on anything that you saw yesterday, you let me know today. Right? Again, it works a lot better if you guys look at it first, and then you come to the second lesson with questions, right? So just remember yesterday we saw these tables of ratios. So if a car had 1 gallon of gas, it could go 20 miles. We saw that you could just continue to build this ratio table by adding the ratio over and over again. So if I add 1 gallon of gas, you add 20 miles. If you add another gallon of gas, it can go again, another 20 miles. Or we saw that you could also do it by, so I can multiply from 1 gallon times 5, 20 times 5 to get to 100, right? And again, if you forgot anything from yesterday, that session is recorded on the class page. Feel free to look at that at your own pace. Okay, this is an example that we did yesterday. We saw an example of how to fill this out. So I'm not going to go over that stuff again. It's all here. It's also recorded yesterday, right? We saw this example of a ratio that wasn't a unit rate. So the dollars wasn't 1 or the cartons wasn't 1. So we did it similarly by adding a ratio or by multiplying. Right, this is the example showing you how to do it. You guys, everybody should have done this part already yesterday. Does anybody have any questions on this section here before I move on? Just let me know. I'll give you about 10 seconds to let me know in the chat or verbally. Okay, I'm getting people saying no, thank you. Okay, so I'm just gonna go on to the next slide, right? So the main thing now is going to figure out how do we use those ratio tables to actually compare 2 different ratios. So remember that example, they talked about the 2 different data plans for the phones. You can make a ratio table for each one and then use those to try and figure out which one might be a better deal, right? That's kind of the goal of what we're doing today. So we're looking at an example today about 2 people that have different cars and they're driving different distances. So it says that both Matt and Zach are planning to drive 120 miles, right? So again, important text, we want to highlight it just so that we can look back at it later and find it easier, right? So they're going to the beach, it's 120 miles away, but they don't know which person's car to take, right? So as they can make their decision by comparing the mileage of Matt's car with the mileage of Zach's car in the given ratio tables below. All right, give me 1 second. So it says because the table of ratios contains equivalent ratios, we'll find a number to multiply each of the first rows by to get to 120 miles. We'll use this method to find the number of gallons of gas each car requires for a 120-mile trip. The car that needs fewer gallons of gas is the one that Matt and Zach will use, all right? So what they're talking about doing here is they're saying, okay, so I know that Matt's car, if I give it 2 gallons of gas, it can go 40 miles. I know that Zach's car, if I give it 3 gallons of gas, it can go 30 miles, right? So the 2 cars, they have different miles per gallon is what we can say, right? They burn fuel at different rates. So the idea is trying to figure out if what their goal is to get up to 120 miles, right? So they want to go 120 miles. We want to figure out, okay, how much gas would he need? Same thing here. If he wants to go 120 miles, how much gas would this car need? The one that needs the least amount of gas is going to be the car that's better to use because you're going to spend less money on gas, right? Right now, gas is probably somewhere around $3 a gallon. I know most of you guys probably aren't driving. So that's something that you might think about when you're going on long trips, is trying to minimize how much money. Just give me a second, I'm adding in somebody coming in late, right? So there's a couple of different ways that you could do this. You could try just going up slowly until you got to there, right? So I could say, for example, let's say I'm looking at Zach's car. Right now I say, okay, so Zach's car, if it has 3 gallons, it goes up to 30 miles. If it has 7 gallons, it goes up to 70 miles. So they're kind of skipping numbers here a little bit. Is anybody able to tell here, right, based on what I see between these numbers, how much, not right now, if this here was to go up from 7 to 8 gallons, how far would this go? How many more miles would I get? Does anybody think they know what that answer is? You can write it in the chat, or you can say it out loud. I'll give you guys a second to think there, because that one they're kind of jumping some numbers up. Okay, so Alfie's telling us it would go up to 80, right? Good. Alexander also said 10, so it's increasing by 10. Good, I'm seeing people getting in the chat. Jaden got it too. Can somebody explain how they figured that out? It would work a lot better if you can just unmute yourself and speak, but if you also just want to type it out, that's going to work too. So what I'm getting is that I heard people say from 70, it's going to go up to 80 miles. And we got that by adding 10. But how did we figure that out? I'll give you guys a second to think about it. So this basically tells us that if I increase 1 gallon, I'm going to go an extra 10 miles, right? If you look at this first row on your table here, you can use this information to figure out what's the unit rate. So if you go 30 miles in 3 gallons, that means that if I were to simplify this fraction or this ratio, I know that 30 over 3 simplifies down to 10 over 1. So that means that if you go 1 mile, you're going to increase by 10 gallons, right? So you can get that from here too. You could also get it from here. Remember, you can find this equivalent ratio from any row on your table. So at this point, right, I could keep increasing. I could say, okay, so I'm going to go up again to 9 gallons. And then from 80, that's going to go up another 10 to 90 miles, right? You could keep going like that. Good, right? Alexander said he looked at the chart, 30 to 3 and 77, and noticed it divided them and gives him 10. Good, right, exactly. So remember, you can always just divide any 2 rows. It doesn't matter which row you use. You use this row, this row, this row. It's always going to give you 10 when you divide this number by that, right? I could keep going up until I get to 120 miles. That would be one approach. Or what you can do is you can try to use the information here and skip the addition and go straight to multiply. So ideally we'd say, okay, if I want to get from 30 miles, the goal is they need to drive 120 miles. So I would say, okay, let's look here. What do I need to multiply 30 by to get to 120? Anybody tell me what that number would be? 30 multiplied by what gives you 120? Right? And if you're not sure, really easy way to figure that question out is to do the opposite. So 120 divided by 30 ends up giving us 4. So what that tells us, right, I'm gonna write on the side over here, 120 divided by 30 equals 4. So what this here tells me is that if I take 30 and I multiply it by 4, I get 120. So remember, if I do something over here, I need to also multiply the other part of the ratio. So I take 3 gallons, multiply that by 4. 3 times 4 is 12. So doing those 2 steps, what this tells me now is that if I give the car 12 gallons of gas, that car is going to be able to go 120 miles, which is what we were looking for before. Right? Now, I would go ahead and try to do the same exact thing for the table above here, right? This one here. If I give the car 2 gallons of gas, it went 40 miles. So again, the goal here was how many miles is it that we're trying to go, right? We're trying to go 120 miles. So I would say, let's say 120 is here. That's the number of miles. What do I need to multiply 40 by to get to 120? 40 times what gives you 120? 4 times 3 is what it's going to end up being. 40 times 3 gives you 120. So again, I also need to scale this side up here. So I multiply this here by 3. 2 times 3 is going to end up giving me 6. So out of these 2 cars, which one looks like it's going to be the better deal? Which car is going to end up using less gas? Is it going to be Matt's car or is it going to be Zach's car? Right? If you said Matt's car, you are correct. Remember, the goal here is to try to use the least amount of gas. That's which car is going to be the better car. So if this car only uses 6 gallons, this car uses twice as much. So you're going to spend twice as much gas if they took Zach's car. So this here is just an example of how you can use ratios to answer a question like this, right? We compared these 2 cars, so now we know that this top car here is the better car. Right? Just please let me know if anything is confusing, if you want me to go over something again. I'm not getting too much verbal feedback right now, so I have to assume that you understand if you're not asking me questions, right? All right, no questions yet, so I'm going to move on. So this is just written out, them explaining basically the same exact thing that we just did, right? So if my explanation didn't seem to make too much sense and you just want to have like a second opinion, another way to see it, or you forget the way that I taught it, you can always look back and read through what they're explaining right here, right? So this here is giving us an example to try on our own. It says, Giselle is baking cookies. The recipe calls for 2 eggs for every 3 cups of flour. So I see that information all the way at the top of my ratio table, right? It says 2 eggs right here, 2 eggs for every 3 cups of flour. So cups of flour, 3. 2 eggs, 3 cups of flour. That's how I read this table, right? And when you're making cookies, when you're baking in particular, they usually say that cooking is like an art, baking is like a science. So when you're baking something in the oven, it's really important to keep the ratio of ingredients correct. So if the ratio is not correct, and I use like say 2 eggs and 2 cups of flour, the cookies aren't going to come out right. So it's really important that you keep that ratio consistent, right? The idea here is that we're scaling up this recipe to make more batches, right? So that you can feed more people with these cookies. So basically what you want to do here is take these numbers and figure out where these numbers are going to end up going in this ratio table, right? And it's really easy to do, especially if you're going in order. You just think about scaling up. So if I went from 3 to 6, I basically doubled the recipe, right? 3 multiplied by 2 ends up giving me 6. So I need to do the same thing over here. If I'm doubling the recipe, I'm now going from 2 eggs up to 4 eggs. And then you would do the same thing again, right? You could say, okay, so if I went now from 2 eggs up to 6 eggs, from here to here, I'm tripling the recipe, right? So I'm making enough for 3 batches. Then I would do the same exact thing on the right-hand side. If I'm tripling the cups of flour, I'm going from 3 cups of flour now up to 9 cups of flour. And that's the idea there. So if you haven't done this already, which ideally we've done this yesterday, you fill this rest of these out, just doing the same thing I did here, right? Any questions before we move on? Right, and also it also works by addition instead of multiplication. So instead of multiplying, I could say, okay, so remember, the ratio is 2 to 3. So every time I add 2 eggs, I need to add 3 cups of flour. Anytime I add another 2 eggs, again, I need to add another 3 cups of flour. So you can fill out these ratio tables either way. You can do it slowly by doing that addition, or you can do it by multiplying, right? Whichever way makes more sense for you, but ideally we want you guys to understand both eventually. Right, no questions, so I'm just gonna continue on, right? So it says, okay, no, that's not a problem. It says compare the price per dozen eggs at the local grocery store. So over here, we've got some prices. So it says 1 dozen eggs costs $3, 2 dozen eggs cost $6, 3 dozen cost $9, and so on. Or at a supermarket, 1 dozen eggs cost $2, 2 dozen eggs cost $4, 3 dozen eggs cost $6. Now it's saying Edward bought 8 dozen eggs at the supermarket. So this is a supermarket, he bought 8 dozen eggs, but it actually doesn't give us a number for 8, right? So you have to do a couple of things for this question, right? To answer this question, I'm not gonna answer it for you, I'm just gonna help get you started here, right? First thing we need to do is we need to figure out how much money is he actually gonna spend to buy, sorry, this pen is not cooperating right now. All right, so how much money is he gonna need to spend to buy 8 dozen eggs? That's gonna cost him how much money at the supermarket, right? And then on top of that, you really wanna be careful with math questions because this question is 2 parts. It says, how much did he save buying eggs at the supermarket, right? I see Jaden told us an approach, you doubled the 4th row, that's a really good strategy, right? So it says, how much did he save buying eggs at the supermarket instead of the local store? So the question isn't asking us how much he spent for the 8 eggs. It's saying, okay, first figure this out here. Then you also have to figure out how much would it cost if he bought 8 dozen eggs here at the grocery store, right? So you're gonna end up with 2 numbers first. You're gonna have the number of eggs, sorry. So 2 things, right? You need to find the price for the eggs at the supermarket. Then you need to find the price of the eggs at the grocery store. Sorry, that's pretty sloppy. Hopefully you can read it. And then if it's asking us how much money he saved by buying them at the supermarket, what am I gonna do with those 2 numbers in the end? Right, one number is gonna be larger than the other. So the way that I find out how much money he saved is you just need to subtract those numbers. Okay, good, thank you, Jade. And again, with math, a lot of times students get things wrong simply because they didn't read the whole question. So a lot of times I would see students answer a question like this. They would just figure out how much 8 dozen eggs costs at the supermarket, or they might find it at the grocery store because they weren't paying attention, and put that as your final answer, right? In this case here, it's multiple choice. So if you calculated that, you would say, wait, my answer is not here. And hopefully at that point, you would reread the question and not just pick one because you're not sure, right? So just always make sure you read the question, make sure you're answering the correct question, right? So again, this part is 3 parts. First, figure out how much he's gonna pay for the eggs at the grocery store, figure out how much he's gonna pay for 8 eggs at the supermarket, and then from there, you subtract those to find the price difference, right? And Jaden gave us a hint. He said something that he did was he doubled the 4th row. So he's talking about this row here, right? But again, there's a lot of strategies that you can use for that. That one is one that works, right? So you want to go ahead and make sure that you answer this question here. And I believe we're pretty much done here. We're up to the summary slide, right? So summary, it says, in this lesson, we learned how to create and fill tables of ratios and how to compare them to find the best option possible. Knowing how to use and compare ratios is useful in situations such as measuring ingredients in recipes, comparing prices and discounts when shopping, and determining unit rates. Comparing ratios can help us make good decisions when we have to choose between different options. For example, before buying groceries that are on sale, it's a good idea to check the unit price on different brands to see if the item really offers the best price. So remember I showed you that example of looking at some items on Amazon to find that unit price. And when choosing a car, you can use ratios to compare the gas mileage of different cars to select the best option, all right? So I know you guys are all still young, but you guys probably get some money here and there from like allowance, gifts, birthdays. You still have to buy things sometimes, and it is good to figure out, you know, how are you gonna get the best for your money? And once you guys are older, you're working, that's gonna become even more important. All right, so at this point, we're pretty much done with the lesson for today. So I'm gonna go ahead and just stop the recording for now.